Imagine you build a RAG system or a retrieval augmented generation system. You documented in and the user question come out, but still answer is wrong. Retrieval irrelevant chunks. And you are sitting there still and thinking about, I did everything right, but what is wrong? And this is where most people get stuck, because knowing the 4 phases of RAG is one thing. Understanding what is actually happening inside each phase is that what separates the RAG system that works from one that works well. So today we are going one level deeper. Same RAG pipeline you already know, but this time we are actually going to look at what is happening inside each step and why it sometimes goes wrong. My name is Salam Lak, and I build RAG systems for real estate and finance companies. And now we have started a new company that focuses on agentic AI, RAG, and AI system, especially for the real estate. And let's get into it for today's topic. Here is something that basic explanations always skips. RAG isn't one pipeline. It is two separate and running separately. There is offline pipeline, there is online pipeline. Offline pipeline runs a background, quietly process your document, chunk them, embed them, storing them in a vector database, that Pinecoin or ChromaDB or other vector database. It doesn't care about user questions. It is just keep the knowledge base ready. Then the online pipeline, this activates at the moment when user asks a question or when the user asks something. Embed the question, search, retrieve, augment, and generate, all in real time. Now here is the critical rule that breaks everything if you ignore it. Both pipeline must use exact same embedding model. The one that embedded your document and the one that embedded the user question have to be identical. If they are different, the vector live in completely different space. Your similarity search will become a meaningless chunks every time. Same model, both sides is not negotiable. So, okay, now you already know embedding converted to vector. And similar meaning, close vector, got it. But here's the part that actually matters for building. With embedding model you choose is the single biggest lever in your entire RAG system. Think about in this way. Imagine you have a document about lease agreement in real estate, and the user asks what are the rental document terms, or what are the rental contract terms. A weak embedding model sees different words: lease versus rental, agreement versus contract, and scores them as dissimilar. Wrong chunk, wrong answer, right? A strong embedding model understands this phrases mean the same thing: correct chunk and correct answer. The LLM at the end doesn't matter if retrieval is failing upstream. You can have the best language model in the world. If it is reading is wrong chunk, it will produce wrong answer confidently. Embedding quietly first and everything else is second. Now here is the one that surprises people. Most RAG failure don't come from the language model. They come from chunking, the steps that happens before everything else. So what goes wrong? Too big chunk. You retrieve 2000 word passage when the answer is one sentence. The model gets flooded with noisy accuracy drops. Too small chunk. You retrieve one sentence with zero context around it. The model doesn't have enough to reason with. Accuracy drop again. The standard starting point that actually works is 512 token per chunk with 128 token of overlap between chunks. This overlap is important. It means the end of one chunk and the start of the next share some context. Nothing yet of mid idea. But honestly, the better approach is semantic changing. Instead of cutting every 512 tokens regardless of what the page is, you split in natural boundaries. End of the sentence, end of the paragraph. You keep ideas whole. And one more thing, attach metadata for every chunk. Source file, page number, date, document ID. This lets you filter Retrieval later. And instead of searching everything, you can say, only look in the document from this year, or only search this specific report. Much more precise answer will be there. And most track bugs live there, right there. Fix chunking first. Okay, so now your chunk are embedded and stored. Now someone asks a question. How does the system find the right chunk out of potentially millions? This is where the vector database does its job. The question gets embedded into a vector, then the database runs something called NNN search, or approximate nearest neighbors search. It compares the question vector against all stored chunks of vector using a cosine similarity. Basically, measuring the angle between vectors and return the top k closest matches. Now you might wonder, why approximate? Why not exact? Because exact search across millions of vectors is incredibly slow. So ANN, or approximate nearest neighbors, trades less than 1% accuracy for 1000 times speed improvement. In practice, you don't notice the difference. In production, you absolutely need speed. Tools like Pipecoin, Wavelet, Chrome, or other databases, these are purpose built for this. They can search hundreds of millions of vectors under 10 microseconds, and a rigorous SQL database cannot close to that. This is why vector database is not optional, it is infrastructure. So now here's the interesting part. There isn't just one way to retrieve chunks. There are three, and choosing the right one is matters. Dense retrieval. This is pure semantic search. Vector comparing meaning. Great when someone asks a natural language question where intent matters. What is the best approach for type question? Sphere retrieval. This is a keyword matching. Uses algorithm called B225, and it is great for exact terms. Product code, proper name, specific number. Things where the exact word really matters. This sphere retrieval is good. And the hybrid retrieval. Dense plus sphere combined. Then rerank by relevance. This is what you should be using in production. Dense handles the intent, sphere handles the exact matches. Together, they cover each other blind spot. Here is the real example. Someone asks, what is the Article 7 clause of 3 contract? Dense searches might be miss the exact clause reference. Sphere search find it immediately. Hybrid gets you both the exact clause and the surrounding context. Best overall accuracy and every time. So the production choice should be hybrid retrieval. Okay, so you have your retrieval chunks, you have the user question, and you might think just throw them together and send it to the LLM, right? That is wrong. The structure of how you build them prompt directly affects your answer quality. Here is the correct order of prompt. System instruction first. This tells the model its role and constraint. Something like, you are a helpful assistant. Answer only based on the provided context. Then the context block, you retrieve chunks injected there. Then the user question at the very end. Context before question is always very important. Why? Because you want the model to read the fact before it sees what it needs to answer. Like, handing someone briefing document before asking them a question. Then they go informed, not by guessing. A properly structured augmented prompt reduces hallucination by 60% compared to sending the question alone without any context. That is not a small improvement. That is the difference between system you can trust and you can't. So let's learn this properly. Now you know what is actually happening inside each phase. And if your RAG system is underperforming, here's what is your debugging checklist. 1. Chunk smart. Size and overlap matters more than anything else. Start 512 tokens with 128 overlap, then 10. Second, same embedding model on both sides. Indexing and querying, never mix them. Third, use the hybrid retrieval. Dense plus phrase, re-ranked, it beats either method alone every time. The fourth, structure your prompt correctly. System instruction, then context, then question. In that order, you will get a good answer. Then fifth is keeping a temperature low between 0 and 0.3 for factual accuracy. Creativity is the enemy here. And the sixth, evaluate the retrieval first. Before blaming the LLM, measure how often the rate chunks comes back. Most people live there, not the language model. Build it in simple first, measure it, then improve chunking, and retrieval before you touch the LLM. That is, so if you get this video useful, please make sure that you hit that like button and make sure to subscribe so you will not miss next breakdown. Thank you for watching and see you next time.